Hi class, this is part 2 of section 3.5. Okay, so we're starting with example 4. We want to graph the following functions using transformations, and we're going to start with this given graph of y equals f of x. Okay, so for the first one, I'll just call it part A here. We have y is equal to f of the quantity x plus 2 and then minus 1. So adding 2 inside, so adding 2 to the x is going to shift our graph to the left 2 units. And then we'll move it down 1 because of the minus 1. Okay, so here in red, I'm going to take these 2 key points up here, so my x-intercepts, and if I move them to the left 2 and down 1, I'll have 2 points on my new function. Same thing with my y-intercept. I'm at 0, -4 right now, so I'm going to take that point to the left 2 and down 1. This is what is called a rigid transformation, so the shape of my graph stays the same. So it should still look like a semicircle. It's just been moved to the left 2 and down 1. Okay, so here it is graphed on Desmos in blue. All right, next we want to look at y equals 2 times f of x. Okay, so the 2 out front is going to be a vertical change. Okay, so vertically stretch it. Okay, and I'm going to come down here and make a t-table to help us. All right, notice I haven't changed my input value. The input value is still x. Okay, so looking on my graph, I'm going to keep these same 2 input values that I have here along my x-axis, so -4 and +4. So -4 and 4. If I plug in -4 to the function f, my graph here is telling me that the output is 0. 0 times 2 is still 0, right? So same thing with 4. So these 2 points here, -4, 0 and +4, 0, are still going to be 2 points on this new function. Okay. Now let's look at the y-intercept. So on my original function, when I plug in 0, the output was -4. So here I'm at 0, -4. So plug in 0 to the function f. F of x is going to be -4, but then we multiply by 2. So for our new function, we're going to end up at -8. So that's way down here. Okay, and let me erase that y-intercept. So we have this new function graphed here in red. Okay, so my graph has been vertically stretched, but the points where we were at 0, since the y values get multiplied by 2, if you're at 0, multiplying by anything isn't going to change it, right? So if you take your graph and you stretch it vertically, that's never going to change your x-intercepts. Okay, so my x-intercept stayed the same, but the y-intercept was at 0, -4, and we're now at 0, -8. Okay, so my circle, my semicircle now looks like a semi-oval. Okay, so here it is graphed on Desmos. Okay, next, call this part C. I have that negative, so that's going to be a reflection. If the negative is out front, that means nothing has happened to the x values, so my x values are staying the same, but my y values, I'm taking the opposite of all of those. So notice in my graph here, these y values are negative since we're below the x-axis. So all of these y values are negative. So I'll have the opposite of a negative, so they'll turn positive. Okay, so that'll just take my graph and reflect it over the x-axis. Okay, so again, a negative out front reflects it over the x-axis. Okay. When we get into parabolas, a negative out front will tell you if the graph opens up or down. So a negative out front means it's opening down, it's been reflected. So a negative out front, whatever you need to do, remember a negative out front reflects it over the x-axis. Okay, so we kind of finish off our circle here, okay, for the graph of negative f of x. Okay, so there it is graphed through Desmos. And then finally, the last one, y equals f of 2 times x. Okay, so this one might be the hardest one. The 2 is with the x, so remember that's going to be a horizontal change. And also remember that horizontal changes are the opposite of what we think. So instead of stretching it by 2, we're going to compress it by 2. So this is a horizontal compression. Okay, so I'm going to make another t-table, but I'm going to include 2x and then y. Okay, so on my original function here, so again, I'm going to look at these key points. So I have -4, sorry, this one's +4, 4, 0, and then -4, 0 here on the left, and then 0, -4 is my y-intercept. Okay, so when I input 4 or -4, I know that my output is going to be 0. But I can't input 4 to my function here, this last one, because the first thing I need to do is multiply that input value by 2, right? So 4 times 2 would be 8. There is no f of 8, right? It's not part of the graph. Okay, so instead of inputting 4 or -4 to the x value, we can only do 2 or -2. And that is because the first thing we do with our input value is multiply it by 2. So 2 times 2 is 4, and -2 times 2 is -4. And now if this input is 4, I can see from my graph that the output is 0. So the point 4, 0 is on my graph. So what that means is that f of 4 is equal to 0, right? So f of 4 equals 0, and that's what we have right here. So if the input, so it doesn't matter if you call it 2x or 4, right? When you input 4, the output is going to be 0. Same thing with the -4. Okay, but remember, I started with 2 and -2. So if the input is 2, multiply it by 2 to get 4, and now input into the function, so we're at 0. Same thing with -2, input -2, multiply it by 2, so we're at 4, f of 4 is 0. Okay, let me erase this and then redo it. So now if my x value is 0, multiply it by 2, we're still at 0, right? So the corresponding y value is -4. So this point here, my y-intercept is going to stay the same. Okay, so I connect them, and it does look like my graph, the black one, has been horizontally compressed by a factor of 2, right? So, or think of it as 1/2, right? Either way. So we're horizontally compressing it, I'm pushing it in, but it doesn't affect the range, it doesn't affect the y values, okay? So for some of our functions, a horizontal compression and a vertical stretch will happen at the same time. So if you think about a function like y equals x squared, if I stretch it vertically, at the same time, you are also compressing it horizontally. So that will happen sometimes, but not always. So this is an example, this semicircle is an example where I can compress it horizontally, okay, but vertically it stays the same. I still go from 0 to -4, okay? And then we had our other example, 2 times f of x, that stretched it vertically, okay, but horizontally we stayed the same. You still went from -4 to 4, okay? So sometimes a horizontal stretch and a vertical compression happen together. Other times they don't. It just depends on the function. Okay. Oh, and then here's our graph on Desmos. So f of 2 times f of 2 times x. All right, example 5. This is for you to complete and turn it through Canvas. So again, I'm giving you a function y equals f of x. And I want you to describe the transformation and then also sketch a graph of f of the quantity x plus 3 minus 2. So what are the two transformations, and then what does the new graph look like? And then also do 3 times f of x. What does that new function look like? All right, and then I do have one more slide to help you with the homework. All right, so example 6, determine the function obtained by the series of transformations. Okay, we are starting with y equals x squared, so that is our parabola. We want to shift it down 3 units, to the left 2 units, and then reflect it about the y-axis. Okay, so the first two we can do together. Let's shift this parabola down 3 units and also to the left 2 units. So I was at the origin, down 3, and to the left 2. I'm now at the point -2, -3, right? And then it still opens up from there. Okay, and now let's write this function. So y equals, start here with left 2 units. Okay, so this is with the x, and we need an x plus 2 because the horizontal change is the opposite. So moving to the left 2, we need x plus 2 inside the parentheses here. That's going to be squared, and then we subtract 3. Okay, good. So far we've done the first two. This graph is our parabola shifted to the left 2 and down 3. Now we want to reflect it about the y-axis and then come up with the graph that corresponds to that, or the function that corresponds to that. Okay, so if I take my graph that I have here right now, it's just drawn in the 3rd quadrant. Okay, so if I reflect it over the y-axis, I'm going to move over here to the 4th quadrant. This would be the point 2, -3. And then these other two guys would also shift over. Okay, so now the vertex's lowest point is in the 4th quadrant as opposed to the 3rd quadrant. Okay, and so let's take our best guess on what the answer is, and then we can double check it. Okay, so reflecting it about the y-axis, okay, the negative is going to be with the x. Okay, if it was opening down, that's when the negative would be out front. That's when you'd have a negative out here. Okay, but ours is still opening up because we reflected it about the y-axis, not the x-axis. Okay, so that's the answer that I'm going to check. I was debating between that and this other answer where, let's see, x, where you have the x plus 2 in parentheses, right? So that would be, that might be like the two things you're debating between, right? So you know you need to have a negative with the x. So going from this answer that we had up here, where we did everything except reflected about the y-axis, when I replace x with a negative x, is it just the x that I change, or do I have to change, you know, the whole thing here inside that's getting squared? Okay, and the answer depends, right? It depends on the order in which you were told to do things. So reflecting about the y-axis, we were asked to do that 3rd. Okay, so you get a different picture if you started with y equals x squared and reflected it about the y-axis first, right? It wouldn't change at all. Okay, so the order in which you do things does make a difference, especially, well, only when reflections are involved, and then it still depends. It's not always going to matter, but in this case it matters. Okay, so let's just figure out which one of these two is the correct answer. Okay, so to do that, we're just going to plug in 2. Okay, we want to see which of these graphs has 2, -3 as a point, right? So this is our key point. This is the vertex. Okay, that's the one that we want to look at. If I plug in a 2 to my first equation, my first guess, plug in a 2 here, I take its opposite, so I'm at -2. Plus 2 is 0, so that's good news. I'll have 0 squared minus 3. So that's the one I want. If I plug a 2 into this other guy, I'm adding 2 to it first. So 2 plus 2 is 4. Its opposite is -4. Square it, we're all the way up to 16, right? So that's not going to get us where we want. Okay, so when a reflection is involved for these type of questions, make your best guess and then check it. Okay, so our first instinct was correct. Kind of the easier way of doing it was the one that worked out. Okay, that's it. So good luck on the homework. Let me know if you have any questions.